All right, everybody. So, excuse me, here's the 2.1 homework, solving inequalities. So, number 15, first thing we're going to see is distribution on both sides of our inequality. So I end up with my 10u plus 15 and my 2u minus 6 plus u. I've got two like terms on my right-hand side, so I'm able to combine 2u and u to get 3u. From there, I subtracted 3u from both sides. From there, I subtracted 15 from both sides. Again, like we've talked about, if you want to combine those two steps, that's fine with me. And then to finish off my problem, I divided by 7, and since I'm dividing by a positive number, I do not need to change my inequality. And so I end up with u is greater than negative 3. I see that I made a minor mistake. We're going to go ahead and fix that. And so on my number line, I know that I've got an open circle at negative 3, and then my graph goes to the right. Again, I prefer that you graph above the actual number line so that it's clear. And remember, I only need 3 values on your number line. I need the value that fits in your inequality. I need to see where 0 is, and then the other number is really up to you. Put it on the other side of 0, though. So what I'm saying, what I mean by that, is if you had happened to put, let's say, 5 here, that would be fine. So number 16, again, I have to begin with some distribution. I distribute 3 to my x and my negative 2. Leads to 3x minus 6 minus 2 is less than x minus 5. I combine my two like terms. I add 8 to the other side. Oh, weird. I lost an x in my next step. So let's make a correction on that. So I end up with x plus 3. From there, I can subtract x from both sides, getting me 2x is less than 3. I divide by 2, and I end up with x is less than 3 over 2. So when I turn to my graph, again, I need to see the value that's in our inequality. I need to see where 0 is located, and then I tend to use opposites, but whatever value you put on the other side of the inequality is up to you. 17, again, starts with some distribution. I distribute my 5 to my x and my negative 7, 2 to my 1 and my negative x, 3 to the x and the negative 11. On the left-hand side, I've got multiple like terms. So I'm able to combine my 5x minus 2x and get 3x. I'm able to combine negative 35 and 2 to get negative 33. I add 33 to both sides, getting me 3x is greater than 3x. I subtract 3x. I get 0 is greater than 0, which I know is a false statement, so there is no solution. Now, some people might have noticed that there was no solution at this step, or they might have noticed at this step. Whatever step you notice it at is fine, but typically most people don't really notice inequalities till they get to the end. 18, like the others, starts with some distribution, so I distribute my 3 to my 2 and my negative 3s, 5 to 2 and to negative s. End up with two like terms on the left-hand side of my inequality. 4s minus 9s is negative 5s. I add 5s to both sides. I get 6 is less than 10, which is a true statement. Without any variables left over, that tells me that I'm going to have all real numbers for my solution. And that means that on the number line, I basically graph a line with arrows on either side above my number line. The values that you choose to put on the number line, again, aren't that important in this case, but I do like to see where 0 is. Excuse me. Number 19, be careful. Make sure you distribute the negative to both terms. So notice I ended up with negative 2y plus 8, negative 2 plus y. I do have a couple like terms on my left-hand side. Lost part of my y. And on my right. 7y minus 2y gets me 5y, 6 minus 2 gets me 4, and I continue solving. I subtract y from both sides, I subtract 8 from both sides, I divide by 4, and y is less than negative 1. Again, on your number line, we need the value from the inequality. I want to see where 0 is, and for the last value, you can really use anything you want on the other side of 0. Like all the rest, I start 20 with distribution. Be careful, make sure you distribute the negative 3. Notice I ended up with negative 3 minus 3x from distributing the negative along with the 3. Of course, I've got a couple like terms now. I've got 8 minus 3. I've got negative 4x and negative 3x. I combine my like terms. Negative 7x plus 5 is less than 5 minus 5x. I add 5x to both sides, subtract 5 from both sides, divide by negative 2. 0 divided by negative 2 is 0, but because I divided by the negative 2, notice I flipped my sign, and I end up with x is greater than 0. 21, more distribution of a negative. So notice when I distributed my negative 3, I got negative 6 plus 12k. I combined, sorry, I didn't distribute on the right-hand side to begin with. I combined like terms to begin with. So I ended up with 9k minus 9. Then I distributed my negative. Notice I got negative 9k plus 9. I add 9k to both sides. End up with 22k minus 6 is less than 16. Add 6 to both sides. Divide by 22 and end up with my final value. 22, again, notice I distributed a negative. On the right-hand side, I just have to distribute the 2. From there, I have like terms. Now, whether you show that you did 2/3 plus 9/3 for 3, that's up to you, but it leads to 11/3 t. I subtract 3t from both sides. Similarly, whether you show that you used 11/3 minus 9/3, that's up to you. I end up back at 2/3 t. Add 2 to both sides. And then to eliminate, I'm going to erase this for a second. To eliminate the coefficient 2/3, I know I can multiply by its reciprocal, 3/2, so that these cancel on the left, leaving me with just t. I can cancel the 2 with the 4, leaving me with 2 times 3, and I end up with t is less than 6. 23, I distribute my 4. I distribute my negative 3. Again, be careful. Make sure you include the negative. Notice on the right-hand side, I got negative 6y minus 3. Nope, sorry about that. Now I can start to combine any like terms that I might have, like y minus 6y, or negative 9y and 4y. I add 5y to both sides. And when I do that, I end up with a statement that is always true. So I know that y could be any real number. And again, I demonstrate that by basically drawing a solid line with arrows on it above my number line. 24, I distribute my negative. I distribute my 2. Again, notice that I distributed the negative and I ended up with negative 3x plus 7. I combine my like terms inside my bracket. 5x minus 3x is 2x. I distribute the 4, ending up with 8x plus 28. I subtract 8x from both sides. And I end up with a statement that is false. 28 is never less than negative 10. So I have no solution. Now, 25, 26, and 27 are kind of logic puzzles, and if you think something is false, all you have to do is provide a single example that shows it's false. Now, if A is less than B, then A minus C is less than B minus C. That is true and hopefully makes sense that if A was already less than B, if we took the exact same amount away from A as we take away from B, we would still have a smaller value on the left. 26. A is less than B. All right. Then A minus B is less than 0. Hopefully this makes sense because if we were going to subtract B, B has the larger absolute value. If B is larger, B has the larger absolute value, which will result in A minus B being less than 0. We end up with a true statement. And then finally, 27, and we've actually discussed this in a different set of problems. A is less than B, then A squared is less than B squared. Well, I know that's false. I can quickly make up an example. Negative 2 is less than 1, but negative 2 squared is greater than 1 squared, so that makes this a false statement. All right, hope this clears some things up. If you still have questions, feel free to ask in class. See you soon.